Hello. Geography of Turkey 1. Welcome to the Physical Geography of Turkey course. In today's session, we will discuss the basic factors and processes in the formation of landforms. Landforms are the result of various geological and geomorphological processes that shape the Earth's surface over long periods. Here are some of the key processes contributing to the formation of different landforms. 1. Plate tectonics. Mountain ranges, formed by the collision of tectonic plates, leading to the uplift of the Earth's crust. Valleys and rifts result from the movement of tectonic plates away from each other. 2. Weathering and erosion. Mountains and hills, shaped by the breakdown of rocks due to weathering and sculpted by erosion from wind, water, and ice. Canyons and valleys, carved by the erosive action of rivers and glaciers. 3. Deposition. Plains, accumulation of sediments, often from rivers, forming flat or gently rolling landscapes. Deltas, formed at the mouths of rivers where sediments are deposited. 4. Volcanic activity. Volcanic mountains, created by the accumulation of lava, ash, and other volcanic materials. Calderas and craters, formed by the collapse of volcanic structures. 5. Glacial processes. Glacial valleys and fjords, carved by the movement of glaciers. Moraines and drumlins, deposits left behind by glaciers. 6. Karst processes. Caves and sinkholes, result from the dissolution of soluble rocks like limestone. 7. Tidal and coastal processes. Coastal features, such as beaches, cliffs, and sea stacks formed by the action of waves, tides, and currents. 8. Impact events. Craters, created by the impact of meteorites or asteroids. 9. Human activities. Anthropogenic landforms, cities, dams, canals, and other structures created by human activities. These processes often interact and overlap, leading to the diverse range of landforms observed on Earth. The geological history of a region and the ongoing interplay of these processes contribute to the dynamic nature of landscapes. Internal processes, also known as endogenic processes, are geological forces and activities that originate from within the Earth and play a significant role in shaping its structure and features. These processes are responsible for the creation of landforms, the movement of tectonic plates, and the formation of Earth's interior. Here are the key internal processes. 1. Plate tectonics. Continental drift, the movement of Earth's continents relative to each other. This concept was proposed by Alfred Wegener and is a fundamental aspect of plate tectonics. Plate boundaries, interactions at plate boundaries, including divergent boundaries, plates move away from each other, leading to the formation of new crust. This occurs at mid-ocean ridges. Convergent boundaries, plates collide, and one may be forced beneath the other in a process called subduction. This can result in mountain formation and volcanic activity. Transform boundaries, plates slide past each other horizontally, causing earthquakes along faults. 2. Volcanic activity. Volcanism, the eruption of molten rock, ash, and gases from the Earth's interior onto the surface. This can lead to the formation of volcanoes, volcanic islands, and various volcanic landforms. 3. Earthquakes. The release of energy in the Earth's crust, often associated with movement along faults. Earthquakes can result from tectonic activity and may lead to the creation of fault lines. 4. Mountain building. Orogeny, the process of mountain formation, typically occurring at convergent plate boundaries where tectonic plates collide and crustal material is uplifted. 5. Faulting. The movement of rocks along faults due to tectonic forces. This can result in the creation of fault lines and changes in the landscape. 6. Isostasy. The balancing of the Earth's crust in response to the redistribution of mass. It leads to adjustments in the elevation of the Earth's surface, particularly in response to processes like erosion and deposition. 7. Magma intrusion. The movement of molten rock, magma, into the Earth's crust. When magma solidifies underground, it forms intrusive igneous features such as dikes, sills, and batholiths. 8. Geothermal activity. The heat generated from the Earth's interior, leading to geothermal phenomena such as hot springs, geysers, and thermal vents. These internal processes collectively contribute to the dynamic nature of the Earth's crust and the continuous evolution of its surface features. The interaction between internal and external processes shapes the landscape we observe today. Plate tectonics is a scientific theory that explains how major landforms are created as a result of Earth's subterranean movements. The theory, which solidified in the 1960s, transformed the Earth's sciences by explaining many phenomena, including mountain-building events, volcanoes, and earthquakes. In plate tectonics, Earth's outermost layer, or lithosphere, made up of the crust and upper mantle, is broken into large rocky plates. These plates lie on top of a partially molten layer of rock called the asthenosphere. Due to the convection of the asthenosphere and lithosphere, the plates move relative to each other at different rates, from 2 to 15 centimeters, 1 to 6 inches, per year. This interaction of tectonic plates is responsible for many different geological formations such as the Himalaya mountain range in Asia, the East African Rift, and the San Andreas Fault in California, United States. The idea that continents moved over time had been proposed before the 20th century. However, a German scientist named Alfred Wegener changed the scientific debate. Wegener published 2 articles about a concept called continental drift in 1912. He suggested that 200 million years ago, a supercontinent he called Pangaea began to break into pieces, its parts moving away from one another. The continents we see today are fragments of that supercontinent. To support his theory, Wegener pointed to matching rock formations and similar fossils in Brazil and West Africa. In addition, South America and Africa looked like they could fit together like puzzle pieces. Despite being dismissed at first, the theory gained steam in the 1950s and 1960s as new data began to support the idea of continental drift. Maps of the ocean floor showed a massive undersea mountain range that almost circled the entire Earth. An American geologist named Harry Hess proposed that these ridges were the result of molten rock rising from the asthenosphere. As it came to the surface, the rock cooled, making new crust and spreading the seafloor away from the ridge in a conveyor belt motion. Millions of years later, the crust would disappear into ocean trenches at places called subduction zones and cycle back into Earth. Magnetic data from the ocean floor and the relatively young age of oceanic crust supported Hess's hypothesis of seafloor spreading. Most volcanoes are found above subduction zones, but some form far away from these plate boundaries. How could this be explained? This question was finally answered in 1963 by a Canadian geologist, John Tuzo Wilson. He proposed that volcanic island chains, like the Hawaiian Islands, are created by fixed hot spots in the mantle. At those places, magma forces its way upward through the moving plate of the sea floor. As the plate moves over the hot spot, one volcanic island after another is formed. Wilson's explanation gave further support to plate tectonics. Today, the theory is almost universally accepted. Turkey is located in a tectonically active region, and its geological features are strongly influenced by the interactions of several major tectonic plates. The key tectonic elements in Turkey are associated with the convergence of the African, Arabian, and Eurasian plates. Here are some notable aspects of plate tectonics in Turkey. 1. North Anatolian Fault, NAF. The North Anatolian Fault is a major right lateral strike-slip fault that runs across northern Turkey from the Aegean Sea in the west to the eastern part of the country. It accommodates the westward motion of the Anatolian Plate relative to the Eurasian Plate. 2. East Anatolian Fault, EAF. The East Anatolian Fault is another major strike-slip fault that runs along the eastern part of Turkey. It accommodates the southward motion of the Anatolian Plate against the Eurasian Plate. 3. Aegean Extensional Regime. The Aegean region is characterized by extensional tectonics, leading to the opening of the Aegean Sea. This extension is associated with the westward motion of the Anatolian Plate and the northward subduction of the African Plate beneath the Eurasian Plate. 4. Hellenic Subduction Zone. South of Turkey, the African Plate is subducting beneath the Eurasian Plate along the Hellenic Subduction Zone. This subduction is associated with seismic and volcanic activity in the eastern Mediterranean. 5. Collision zones. The collision between the African and Eurasian plates in the eastern Mediterranean and the convergence of the Anatolian Plate with the Eurasian Plate contribute to the complex tectonics in the region. 6. Anatolian Block. Turkey is often referred to as the Anatolian Block or Anatolian Plate, which is a microplate caught between the converging Eurasian, African, and Arabian plates. The motion of this block is critical in understanding the seismic activity in the region. 7. Seismic activity. Turkey is prone to significant seismic activity due to the interactions of multiple tectonic plates. Earthquakes are relatively common, and historical records document several major seismic events. The dynamic nature of plate interactions in Turkey has geological consequences, including the formation of mountain ranges, fault lines, and seismic hazards. The complex tectonic setting of the region makes it important for earthquake studies and monitoring to understand and mitigate seismic risks. Volcanic activities involve various processes associated with the movement of magma from the Earth's interior to the surface. Here are the key volcanic activities. 1. Magma formation. Volcanic activity begins with the formation of magma, a mixture of molten rock, gases, and minerals, beneath the Earth's surface. This process occurs in the mantle and can be triggered by factors such as heat, pressure, and the addition of water. 2. Magma ascent. Once formed, magma rises through the Earth's crust due to its lower density compared to surrounding rocks. The ascent is driven by buoyancy, and the magma can move through fractures and conduits in the crust. 3. Volcanic eruptions. Volcanic eruptions occur when magma reaches the Earth's surface. The type of eruption can vary, ranging from explosive eruptions that release ash, gases, and lava to effusive eruptions characterized by the relatively gentle flow of lava. 4. Lava flows. Lava is molten rock that has reached the Earth's surface. It can flow downhill, covering the landscape and forming volcanic features like lava plateaus, basalt plains, and volcanic islands. 5. Ash and tephra emissions. Explosive volcanic eruptions can release ash, tephra, fragmented volcanic material, and gases into the atmosphere. Ash clouds can travel long distances and impact weather patterns. 6. Pyroclastic flows. These are fast-moving currents of hot gas, ash, and volcanic rocks that move downhill from a volcanic vent during explosive eruptions. Pyroclastic flows are extremely destructive and can reach high speeds. 7. Volcanic gases. Volcanoes emit gases such as water vapor, carbon dioxide, sulfur dioxide, and others. These gases can contribute to atmospheric changes and, in some cases, pose hazards to human health. 8. Volcanic landforms. Various landforms are created by volcanic activities, including calderas, craters, volcanic cones, such as stratovolcanoes and shield volcanoes, and lava plateaus. 9. Geothermal activity. Volcanic regions often exhibit geothermal activity, including hot springs, geysers, and fumaroles. These features result from the circulation of water through the Earth's crust, where it is heated by magma. 10. Volcanic earthquakes. The movement of magma beneath the Earth's surface can induce volcanic earthquakes. These earthquakes may signal an impending eruption and contribute to the monitoring of volcanic activity. Understanding volcanic activities is crucial for assessing volcanic hazards, mitigating risks to human populations, and utilizing geothermal resources. Volcanic monitoring, research, and hazard assessment play essential roles in volcanic regions worldwide. Volcanic activities in Turkey are primarily associated with the tectonic interactions and the presence of several active volcanic centers. Here are some notable volcanic features and activities in Turkey. 1. Mount Ararat, Agirdag. Mount Ararat, located in the eastern part of Turkey, is the highest peak in the country and is associated with volcanic activity. While the last confirmed eruption occurred in the 19th century, the region is seismically active, and there is ongoing geothermal activity. 2. Cappadocia. The unique landscape of Cappadocia, known for its fairy chimneys and cave dwellings, was formed through a combination of volcanic activity and erosion. The region contains volcanic tuff and ash deposits. 3. Mount Erciyes. Mount Erciyes, located in central Turkey near Kayseri, is an ancient stratovolcano. Though it is currently considered dormant, its geological history includes past volcanic activity. 4. Hasan Dag and Melendiz Volcanic Plateau. Hasan Dag is a stratovolcano located in central Turkey. The surrounding Melendiz Volcanic Plateau contains evidence of past volcanic activity, including lava flows and volcanic cones. 5. Aegean Volcanic Arc. The Aegean region, including some of the Greek islands and western Turkey, is part of the Aegean Volcanic Arc. This area is characterized by active and dormant volcanic centers. Notable islands with volcanic activity include Santorini and Nisairos. 6. Karapınar Geothermal Fields. Located in central Turkey, the Karapınar geothermal fields demonstrate geothermal activity associated with the presence of hot springs and geysers. Geothermal energy is harnessed for power generation in this region. 7. Nemrut Caldera. The Nemrut Caldera, located in the eastern part of Turkey, is associated with volcanic activity. The caldera contains a lake, and the region is seismically active. While Turkey is not as well known for frequent volcanic eruptions as some other regions, its geological history and ongoing seismic activity highlight the presence of volcanic features. Monitoring and studying these volcanic areas are important for understanding potential hazards and utilizing geothermal resources. Earthquakes are caused by the sudden release of energy in the Earth's crust, leading to the generation of seismic waves. The primary causes of earthquakes are associated with the movement of the Earth's tectonic plates. Here's an overview of the formation of earthquakes. 1. Tectonic plate movement. The Earth's outer shell, called the lithosphere, is divided into several large and rigid plates known as tectonic plates. These plates float on the semi-fluid asthenosphere beneath them. The movement of these plates is a key factor in the formation of earthquakes. 2. Plate boundaries. Most earthquakes occur near tectonic plate boundaries, where these plates interact. There are several types of plate boundaries. Divergent boundaries, plates move away from each other. Convergent boundaries, plates move toward each other. Transform boundaries, plates slide past each other horizontally. 3. Stress accumulation. As tectonic plates interact, stress builds up along faults, cracks or fractures in the Earth's crust, due to the resistance of rocks to deformation. Stress can accumulate over long periods, leading to the bending, stretching, or breaking of rocks along faults. 4. Elastic rebound. When the accumulated stress exceeds the strength of the rocks, it causes them to deform elastically. When the rocks can no longer withstand the stress, they suddenly break or slip along a fault, releasing stored energy. This sudden release is known as elastic rebound. 5. Generation of seismic waves. The rapid release of energy generates seismic waves that radiate outward from the earthquake's focus, the point where the rocks first break, to the Earth's surface. The point on the surface directly above the focus is called the epicenter. 6. Types of seismic waves. There are three main types of seismic waves. Primary, P, waves, fastest seismic waves that travel through solids and liquids. Secondary, S, waves, slower waves that only travel through solids. Surface waves, travel along the Earth's surface and are responsible for most of the damage caused by earthquakes. 7. Measurement. Earthquakes are measured using seismometers, seismographs. The magnitude of an earthquake is a measure of the energy released, while the intensity assesses the degree of shaking at specific locations. 8. Aftershocks. Aftershocks are smaller earthquakes that can occur in the same area following a major earthquake. They result from adjustments in the Earth's crust to the changes caused by the main shock. Understanding the processes leading to earthquakes is crucial for earthquake monitoring, prediction, and preparedness. Scientists use seismological data and models to study earthquake patterns, assess risks, and develop strategies for minimizing the impact of earthquakes on communities. Earthquakes play a significant role in shaping landforms, and Turkey is located in a seismically active region due to its position at the convergence of several tectonic plates. The complex tectonic setting has led to various landforms resulting from earthquake-related processes. Here are some examples. 1. Mountain ranges. The collision and convergence of tectonic plates, such as the Eurasian plate and the Anatolian plate, have resulted in the uplift of mountain ranges. The Pontic Mountains in the north and the Taurus Mountains in the south of Turkey are examples of regions where tectonic activity, including earthquakes, has led to significant uplift. 2. Faults and rift valleys. Earthquakes often occur along faults, which are fractures in the Earth's crust. The North Anatolian Fault, NAF, and the East Anatolian Fault, EAF, are two major strike-slip faults in Turkey. The movement along these faults has created rift valleys, such as the Büyük Menderes Graben. 3. Uplifted coastal landforms. Coastal regions in Turkey have experienced uplift and subsidence due to tectonic activity. Earthquakes along the North Anatolian Fault have influenced the vertical movement of land along the coast, impacting coastal landforms. 4. Submarine earthquakes and seafloor deformation. The complex tectonic interactions in the Aegean and Mediterranean seas, including the collision of the African and Eurasian plates, lead to submarine earthquakes. These earthquakes can cause seafloor deformation, contributing to the creation of undersea landforms. 5. Landslides. Earthquakes can trigger landslides in mountainous regions. Steep slopes and earthquake-induced ground shaking may lead to the movement of rock and debris downslope, shaping the landscape. Landslides are common in areas with a history of seismic activity. 6. Aftershock landforms. Aftershocks following significant earthquakes can contribute to further changes in the landscape. They may cause additional ground movement, affecting slopes, river channels, and other landforms. 7. River channel changes. Earthquakes can alter river channels and drainage patterns. Seismic activity may lead to the formation of new channels, changes in river gradients, and adjustments in the overall topography of river basins. It's important to note that while earthquakes contribute to the formation of certain landforms, other geological processes, such as erosion, weathering, and sedimentation, also play essential roles in shaping the landscape over geological time scales. The combination of these processes results in the diverse and dynamic landforms observed in Turkey. Mountain building, scientifically known as orogeny, is a geological process involving the formation of mountain ranges. Orogeny occurs due to the interactions between tectonic plates, and it often involves processes such as subduction, collision, and crustal deformation. Here are some details about the mountain building process. 1. Subduction zone orogeny. In subduction zones, one tectonic plate is forced beneath another in a process known as subduction. As the subducting plate descends into the Earth's mantle, it can lead to the melting of rock, generating magma. This magma can rise to the surface, creating volcanic arcs and contributing to the formation of mountain ranges parallel to the subduction zone. 2. Collisional orogeny. When two tectonic plates collide, neither plate subducts beneath the other due to their similar densities. Instead, the intense pressure and heat generated by the collision can cause both plates to crumple and fold, leading to the formation of extensive mountain ranges. The collision between the Indian plate and the Eurasian plate, for example, has given rise to the Himalayan mountain range. 3. Continental rifting and rift orogeny. In some cases, the stretching and thinning of the Earth's crust can result in continental rifting. As the crust pulls apart, it creates rift valleys and, eventually, new ocean basins. The East African Rift is an example of a developing rift valley where orogenic processes may be contributing to the formation of new mountains. 4. Crustal deformation and uplift. Tectonic forces can cause significant deformation of the Earth's crust. Compressional forces lead to crustal shortening and folding, resulting in the uplift of large blocks of crust to form mountain ranges. The Appalachian Mountains in North America and the Alps in Europe are examples of mountain ranges formed through crustal deformation. 5. Isostatic rebound. Isostatic rebound occurs when the Earth's crust adjusts to changes in surface loads. For example, the melting of large ice sheets during glacial periods removes a significant weight from the crust. As a result, the crust gradually rebounds or uplifts to reach a new equilibrium, influencing the formation of certain mountainous regions. 6. Magmatic intrusions. Intrusions of magma into the Earth's crust can lead to the formation of mountain ranges. As magma rises and solidifies beneath the surface, it can uplift and create domes or mountainous features. The Black Hills in South Dakota, USA, are an example of a region where magmatic intrusions have influenced mountain formation. Overall, orogeny is a complex and dynamic process that involves the interplay of various geological forces, and it plays a crucial role in shaping the Earth's topography over geological time scales. Turkey, with its complex tectonic setting, has been shaped by various mountain building processes or orogeny throughout geological history. The country is situated at the convergence of several major tectonic plates, including the Eurasian, Arabian, and African plates. Here are some key aspects of mountain building, orogeny, in Turkey. 1. Collision of tectonic plates. One of the significant contributors to mountain building in Turkey is the collision between the Eurasian plate to the north and the African and Arabian plates to the south. The collision between these plates has led to the formation of several mountain ranges. 2. Anatolian Plateau uplift. The Anatolian Plateau, located between the converging plates, has experienced uplift and deformation. The interaction between the plates has caused the Anatolian Plateau to rise, and this ongoing tectonic activity contributes to the formation of mountainous regions. 3. Taurus Mountains. The Taurus Mountains, running parallel to the southern coast of Turkey, are associated with the collision between the African and Eurasian plates. The convergence and crustal deformation in this region have led to the uplift of the Taurus Mountains. 4. Pontic Mountains. The Pontic Mountains, located to the northeast of Turkey along the Black Sea coast, have been influenced by the collision between the Eurasian plate and the Anatolian plate. This collision has resulted in uplift and the formation of mountainous terrain. 5. North Anatolian Fault, NAF. The North Anatolian Fault is a major strike-slip fault that accommodates the westward motion of the Anatolian Plate. The fault zone has experienced significant crustal deformation, creating diverse topographic features and contributing to the formation of mountainous landscapes. 6. East Anatolian Fault, EAF. The East Anatolian Fault, situated to the east of Turkey, is another tectonic boundary where the Anatolian Plate interacts with the Arabian Plate. This fault system has played a role in the uplift and deformation of the eastern part of the country. 7. Extensional tectonics. In addition to compressional forces causing uplift, extensional tectonics have played a role in shaping certain regions. The process of crustal extension and rifting has influenced the formation of grabens and horsts, contributing to the topographic diversity in Turkey. 8. Volcanic activity. Volcanic activity associated with subduction zones and extensional tectonics has contributed to the formation of volcanic mountains in Turkey. The region has several volcanic centers, and their activity has influenced the landscape. Overall, the complex interactions between tectonic plates, fault systems, and volcanic activity have collectively shaped the mountainous terrain in Turkey. The geological history of the region reflects the ongoing processes of orogeny that continue to influence the landscape. Faulting is a geological process characterized by the movement of rocks along fractures or zones of weakness in the Earth's crust. It plays a crucial role in shaping the Earth's surface and is often associated with earthquakes. Here are some details about faulting. 1. Definition of fault. A fault is a fracture or zone of fractures in the Earth's crust where rocks on one side have moved relative to rocks on the other side. The movement along a fault can be horizontal, vertical, or oblique. 2. Types of faults. There are several types of faults, including normal faults. These occur when the hanging wall, above the fault, moves downward relative to the footwall, below the fault. Normal faults are associated with extensional tectonics. Reverse faults, thrust faults. In reverse faults, the hanging wall moves upward relative to the footwall. Thrust faults are common in compressional tectonic settings. Strike-slip faults. Strike-slip faults are characterized by horizontal movement along the fault. The rocks on either side move past each other horizontally. 3. Fault plane. The fault plane is the surface along which the movement occurs. It is the boundary between the two blocks of rock that have shifted. 4. Fault trace. The fault trace is the line on the Earth's surface that represents the intersection of the fault plane with the ground. 5. Fault scarp. A fault scarp is a small, cliff-like feature on the Earth's surface that is formed by the movement along a fault. 6. Fault system. Faults are often part of larger fault systems that can extend over significant distances. These systems may consist of multiple parallel or intersecting faults. 7. Fault zones. Fault zones are broader areas that include a network of faults and associated fractures. These zones can exhibit complex interactions between faults. 8. Earthquakes. Faulting is a primary cause of earthquakes. When stress along a fault exceeds the strength of the rocks, it can result in sudden movements and the release of energy, leading to seismic events. In the context of Turkey, the North Anatolian Fault, NAF, and the East Anatolian Fault, EAF, are two major strike-slip faults that play a significant role in the tectonics of the region. The NAF accommodates the westward motion of the Anatolian Plate relative to the Eurasian Plate, while the EAF marks the boundary between the Anatolian Plate and the Arabian Plate. These faults contribute to the seismic activity and the complex geological landscape in Turkey.